Hi everyone, I'm going to be going over some common mistakes that are found in pretty much all math topics. And as you can see on part of your screen, the most common mistake is the sign mistake. So let's get started. So sign mistakes, when negative 6 magically becomes positive 6. It's magic. Well, this is pretty annoying because when you're in the middle of a big problem and you make a mistake and you forget that there's a negative there, it can derail your entire work and make a problem that was once solvable completely unsolvable. So the main fix for this is you have to write neatly, and your minus should look like a minus. Another thing that I can do is, let's say I had the number negative 4, right? So I wrote negative 4x plus 3. And the next step, let's say I was adding 2 to that, so I got negative 4x plus 5. So I wrote negative 4x plus 5 now, because I've added 2 from some operation, assuming this is an equation. Now what you can do is, you see your negative 4x here, what you can do is you put a check here after verifying that these negative signs match. So let's say if you forgot this sign, then you immediately look back here and be like, oh, I forgot this. You put it back, and then you put a check mark saying, hey, I did this. So that's how you can make sure that you aren't making as many sign mistakes. Another thing is, if you have, let's say you're doing some distribution, for example, when you had minus 2 times 2x minus 3. Another thing you can do is, not just for the negative sign, but also for the numbers, what you should do is draw an arrow like this, draw an arrow like that, and then you can multiply it and get negative 4x minus 2 times 2 is negative 4. And then the minus multiplies to the minus, and you get a plus, so in plus 6. And you can make sure that this minus is in fact, it should be negative, and these two negatives become a positive, so you're good. The next common mistake is intermediate operations. And one pretty annoying example is when 1 over x becomes 1 over x, which is obviously wrong. The main fix is, don't do complex steps in your head, because if you have something like this, always write an additional step saying since a fraction is essentially a division, also make sure this line is longer, but also do 1 divided by 1 over x, then do keep change flip, and you say that it's equal to 1 times x over 1, which is 1 times x, and that becomes x. It's not 1 over x, that's wrong. Let's see, the next one is numbers. So this happens a lot, especially in matrices. Like I made this mistake myself. I had a 12 in one matrix, and I was copying that over to another matrix, and I think I was doing a row echelon operation, where I had to multiply a row and do some subtraction and stuff, and I wasn't operating on that row, so I said to copy that row over to the next matrix I was using. And the 12 became a 2 when it wasn't supposed to be. And as you can see, like this 1 is like right next to here. That's one thing. Another thing is, if you have like a bunch of numbers really close to each other, like let's say I had, like trying to fit a 3 by 3 matrix in this kind of space, let's say I had 1, 2, 3, so on. This is wrong. Write them big, that way you won't make a mistake. So you can do 1, 2, 3. So give yourself a little bit of space. I don't know about your teacher, but my teacher gives you like a full page for each problem, so you have enough space to do this. Don't write super small. You're not going to gain anything from it. You're going to lose. Another thing is also write neatly. So this is a 0, right? Don't make it look like a 6. Oh, that's a 6. Don't make it look like this. This looks kind of like a 6. And if you're writing a 6, don't make it look like a 0. Don't do like this. This is easily confusable you can confuse it easily with a 0. Another thing is, if you're one of those people who writes ones like this without a thing at the bottom, or you tend to forget this, now this looks too much like a 7, and you can get easily confused. Also, if you're writing a 2 and you're writing it real fast, this can look like a z, so if you're operating the variable z, be very careful about that. Also, if you're writing real fast, it can also look like a 7. And similarly, if you write 7 like this, it can begin to look like a 2. So what I've seen some people do with this is they sometimes write a 7 with a bar in the middle like this. This is very helpful. And you can safely write the 1 and the 2 without forgetting. Also, if you're writing your 1, don't make it look like a 2, so don't write like this. It looks more like a 2 than a 1. So be very diligent, make sure that this is a 1, this is a 2. Be very careful about this. Make sure you're not making mistakes, because this usually happens when you're in a hurry. So even if you're in a hurry, make sure you're writing your numbers neatly, because then it increases your chances of solving the problem correctly. Because as I said before, these kind of tiny mistakes, even though as much as you might know how to do the problem, you might know the concept, they're annoying, to say the least. The next one is equations. Is check your solutions and don't use the same equation that you found the numbers with. So if you had, this is like found in matrices and you have row echelon or simultaneous equations. So this is a simple simultaneous equation problem. See if I can get it to fit in the screen. All right, there we go. So if I had this thing, let's say two equations, 5x plus 5y equals 10, x plus 2y equals 3. I multiply this equation by 5 to get rid of the x. Now I'm subtracting the two equations, right? 5 minus 10 is negative 5, not positive 5. We make these mistakes. This happens. One thing you can do to make sure you're not making mistakes is draw a little negative sign down here. And don't forget, so 10 minus 15, okay, that's negative 5. But assuming we made this mistake, right? We have to say 5y equals negative 5, y equals negative 1. We continue solving to find x. We get x equals 3. Now, the one mistake that people make is they try to put it in the same equation they found x with. So don't use this equation, use this guy to check your work. So let's say we checked it with the first equation, which we already used. We get 15 minus 5, 10. It checks out. But if we check with the other equation, it doesn't. We get 1 is equal to 3, which is wrong. That's definitely wrong. So always check with the other equation, because now we know this is wrong. We can retrace our steps and be like, oh, this should have been negative. And then we can, assuming we have time, we can resolve the problem. So this is very important. And also coupled with the tip I gave you above about the signs, this can also help you make sure that you don't make these kind of mistakes. But assuming you do, this is like your backup. What else? Okay, so we've gone over the 4 most common mistakes. As if you've paid attention, you notice that these make the word sign. Yes, this guy. Oh, yeah, it makes this guy. It's not sin, it's sign. And it's easy to remember because you remember the trig function and also the acronym SIGN. Signs, intermediate operations, numbers, and equations. So this is the acronym you should remember if you want to make sure you're not making it. So right at the top right corner of the page or somewhere in the margin maybe, preferably it says write sign. Oh, that's off screen. Write it right there. So write like somewhere up here. And then as you check, when you finish the problem, make sure you've checked all these. Just put a little check mark like there. And speaking of check marks, when you have this negative number over here, do not put the check mark over here. Then it looks like, then if you're in a hurry, look at it, oh, it's a positive. No, it should be like up here, somewhere, like keep it away from the negative signs in general. The check mark and the negative signs are not friends. Keep them away. Okay, some other tidbits. Here's some stuff. The calculator. They're awesome, but only if you feed them the right information. So let's say I have, see if I can I have my graphing calculator here. Now, let's say I was typing in the number 125. Simple enough. But if I'm in a hurry, and let's say I had to add 125 plus 125, we know it's 250, but let's say I was adding that on the calculator, and I forgot to do the 5. So I said, oh, I was in a hurry. I was like, oh, didn't hit the 5 key, so 1, 2, and I did 1, 2, 5. 137. We know it's 250. It was quite obvious. But let's say we had some random ones. Let's say I said 384 plus 456. Okay, fine. That's 840. But then, let's say I mistyped, for example, or I forgot a number. I did 387 by accident. Now I have 843. Doesn't seem too off, but this can derail your problem. So always verify, make sure you're typing in the right thing. We want the 384, we don't want the 387. We want this, don't want that. So make sure that what you're typing in the calculator is the right number. Next thing, underline the important parts of the question. Remember what is being asked. For example, let's say there's things they're asking for an equation. So let's say you had a synthetic division problem, and your teacher asks, I need an equation for this polynomial, solve using synthetic division. Don't just write the factor. Don't say like x minus 3, x plus 2, x minus 1, x plus 4. They're asking for an equation. So remember, you have to put an equation. So, like for example, if the polynomial is f of x, remember to write the f of x. So that this becomes an equation. The next point, which is very important, is reducing and rationalizing. So reducing is, if, let's say I had a fraction, 5 over 10. It's obvious this is 1 over 2. But let's say I had a more complex fraction. I can't think of one off the top of my head. Let's say I had 96 over 64. Now I could do this by hand. And I could solve this by hand. But for the sake of time, I want to use my calculator, right? So you can do that on the calculator, that's fine. But make sure you're punching the right numbers. And if you're reducing, like put it in the calculator. Make sure you're using the fraction button. Don't just do division. That'll give you a decimal. So use the fraction button on your calculator and make sure that this is reducing. So I know that on at least the TI-84s, or at least the plus CE, which is what I have, the color model, if you hit the fraction button, you just pull up the fraction here, then 96 over 64, it'll give me 3 over 2, which is the correct reduced function. Yeah, I knew the answer to this one. And I think if you have one of these scientific calculators, again made by TI, these should, again, adjust the lamp here. Yeah, you should be able to see the screen slightly better now. It's still kind of dark. There we go. Yeah, you should be able to see the screen better now. If I did 96 over 64. Yep, that gives you 3 over 2. So some calculators will reduce this for you. So if you have this, use it to your advantage. Don't miss out on this, because this will save you a lot of time, especially if you're finding, like, let's say you're using Cramer's rule in matrices, or you have to reduce some other fraction. This can really help you and save some time, rather than you trying to manually figure out reduce the fraction. And if you make a mistake, then it sucks for you. So use the calculator. If you're going to do it by hand, let's say you have to do it by hand, you can use this to check your work, assuming you have it with you. Okay, the next one I was saying, underline the important parts of the question. Here I had an example. Here we go. A typical marathon is 26.2 miles. Alan averages 12 kilometers per hour when running. This camera, here we go. Averages 12 kilometers per hour when running in marathons. Determine how long it would take Alan to complete a marathon to the nearest tenth of an hour, and justify your answer. Okay, so this is from an old Algebra Regents. It's actually from another, and this specific question is from another video of mine. I'll put a link somewhere, and you can click on that. But as you can see, I've put a box around 26.2 miles. I put a box around 12 kilometers per hour. I've underlined how long it would take Alan to complete a marathon to the nearest tenth of an hour. Now, the nearest tenth is super, 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 super important. This is very, very, very important. If you round to the nearest 100th, you lost a point. If you round to the nearest 1,000th, you lost a point. If you round to the nearest whole number, you lost a point. Also, justify an answer. Don't just give an answer. Make sure that you give an explanation if an explanation is needed. So that's underline the important parts of the question. But other than that, these are the most important things. Remember, the acronym is SINE, science, intermediate operations, numbers, equations, and also these other tidbits that I mentioned. And most importantly, do not forget to subscribe and look for more videos. And thank you. There's also one other important thing that I didn't mention, but I feel like it's important to mention anyway. Another thing is degree versus radian mode, and also stat diagnostics. So if I reset the calculator here, right now you see it's in radian, so I'll put it in degree real quick. If I reset the calculator, Right now you see now it's back in radian mode. This is important because the TID4 models are by default in radian mode. Color models will tell you this with the status bar at the top, but other calculators won't. So you have to be very careful and make sure you're in the right mode before you perform any trigonometric calculations. So it's easy to do. All you have to hit is mode, and you go down to the radian degree row and choose whichever one you want by hitting enter. Now, only the graphing calculators tend to stick in radian mode by default. If I pull my scientific calculator here, and I reset it real quick, let's turn it on to reset. Yes, I want to reset it. Okay, so memory is cleared. As you can see, it's in degree mode. Now, if I change it to radians, and then I reset it again, there, it goes back to degrees. So scientific calculators are by default in degrees, or most of them. So if you're doing calculations mainly in degrees, you shouldn't need to worry about any of the problems here. This mainly concerns the graphing calculators. Another thing I want to mention, which is specific to graphing calculators, is stat diagnostics. Now, what that lets you do is shows you the correlation coefficient when you perform a linear regression. So if I hit mode, on the color calculators, this is easy to turn on, and all I have to do is simply hit mode and go all the way down to stat diagnostics and change that to on by selecting on and hitting enter. On the black and white models, even on the color models, it's the same process. You can hit second, 0, go to the catalog, then hit the -1 power, or the inverse button. The blue print in it will say matrix over it, and in green letters it'll be a D. So you hit that, it'll scroll all the way down to the D. And then you can just use the down arrow to scroll down to diagnostic on. Now, don't confuse it with diagnostic off. They're right next to each other. We want to turn them on. So hit enter once to paste it into the command prompt, and you hit enter again. And there should be a done on your screen. So now, if I enter some items into a list, let's see. Let's do 1, 2, 3, 4, 6, 7, 8, 9, and then I can enter 1, 3, 7, 9, 11, 13, 15, 17. So now if I do a linear regression on that, let's see, linreg, let's store it in our, this is another thing you can do. Is it's a nifty trick. If you go to store reg eq, you hit vars, go to yvars, hit function, and choose y1 or whatever, anyone that's empty. It will actually calculate the linear regression and store it in the y equals menu, so that you don't have to worry about writing it down and then copying it back there again, which leads to less errors. So if I hit calculate, as you can see, it calculated a line, and with a correlation coefficient of 1, meaning it was a perfect fit. And as you go to y equals, it will be right there. And I can hit graph, and it's graphed. If you're doing stuff with plots, also make sure to turn the plot 1 on, which will end up showing the points, like so. And now you can see the line fits them perfectly. So, again, thanks for watching.